Hello everybody, welcome back. This is going to be 6-2, which is going to be all about pressure and how pressure is going to have a big effect on gases. So when we do pressure, there's a few things that we need to understand about it. What we're talking about is gas pressure itself is defined as a force acting on a specific area. So if you've got a force on a specific area, we define pressure as force over area, or force per unit area. And so you can have several different units. The unit that we most use in calculations is going to be the atmosphere, because that is the scientific unit that we use, and all scientists can go to that. In America, we use millimeters of mercury. 760 millimeters of mercury is equal to 1 atmosphere. 760 torr is also equal to 1 atmosphere, and so that means that a torr and a millimeter of mercury are the same thing. So if you see those in a problem, they are equal. Pounds per square inch, you may see that and have to convert it. Pascals or kilopascals, notice that there is a decimal when you do the kilopascal, and this is 101,325 pascals. So those are just some of the conversion factors that we may use to work some problems. And these are some examples of atmospheric pressure on Earth. At sea level, as I said, we are 0, okay? So 0 kilometers of altitude, we have 1 atmosphere of pressure. Los Angeles also on the coast, so it's pretty close. But you go to Denver. Denver is 1.6 kilometers above sea level, and so you have a lower pressure. The higher you go, okay, the higher you go, the lower the pressure, okay? And that's because the air's thinner, if that makes sense. That's in the air, okay? The deeper you go under the water, okay, the higher the pressure will be, and it's at a greater rate, because water obviously has more mass than air does. And so to check our learning, if you have 475 millimeters of mercury, can you convert that to atmospheres? You know that we have 475 millimeters of mercury. And what conversion factor would you use to do that? 1 atmosphere is the same thing as 760 millimeters of mercury, right? That's how we'd set that up. And if you have 2 atmospheres in the case of this, then you would flip that over. We're looking for millimeters of mercury. So 1 atmosphere is the same as 760 millimeters of mercury. Okay, and so that would give us, I can do that in my head, I think, 1420 millimeters of mercury on that one. This one I'd have to do my calculator on. So that would be 475 divided by 760, which should be 0.63 atmospheres. Okay, and I can get that because, remember, when I do this, I can cross multiply and I can cancel out those. Alright, and we did get the same thing, so that's good. Oh, whoops, I shouldn't have done that one in my head, because it was actually 1520, wasn't it? So I'm sure you were smart and did it on your calculator. How we measure pressure is with a barometer. And you've probably heard of a barometer, and ships use these a lot, and you can see them sometimes in homes, and there's different kinds. But basically they measure the pressure exerted by the gases in the atmosphere. Remember, we don't just have oxygen, we have nitrogen and some other gases involved. And so a simple barometer could use mercury, because mercury is very dense, and so it's very, very dense, so the height of our tube doesn't have to be very tall. And so you have a vacuum in here, basically, and so if you don't have anything in it, when the pressure from the atmosphere pushes, it will push that mercury up into the tube. And so remember that in this column, that's where this comes from, that 1 atmosphere will cause this to rise 760 millimeters. And so that's where the definition of atmospheric pressure actually came from originally. So in atmospheric pressure, it's the pressure exerted by the column of air that's on top of the Earth. Okay? And that's why if you're at sea level, then it's going to be 1 atmosphere. If you're higher than sea level, it's going to be less. Because remember, just like if you've ever been in Denver or someplace like that, you know when you get to altitude, the air is literally thinner and thinner, and there's less oxygen. Okay? So the relationship is it decreases as altitude increases. It's 1 atmosphere at sea level. And also, check this statement out. The atmospheric pressure is higher on a rainy day. Why is that? If you've ever been outside and the air just felt thick, okay, it was muggy, we call it. Okay, that's because there's a high percentage of water droplets in the air, and the more of that you have, obviously the heavier that's going to be, so that increases our atmospheric pressure. And you'll hear the weathermen say, you know, the barometer is rising or it's falling or whatever, and that's they used to use that and just that to predict when the storms were coming. Now they use computers, of course, but they're basically using the same type of information. So if you want to stop this and try this on your own and then come back to me, you can. Otherwise, I'm going to work this learning check for you. Remember, these are as handouts that you can print off. The downward pressure of the mercury in a barometer is greater than, less than, or the same as the pressure of the atmosphere. The downward pressure of the mercury in a barometer is greater than, less than, or the same as the pressure of the atmosphere. What do you think? It's the same, right? Okay, so if I were to use water, because remember we were talking about mercury, right? So if I was going to use a water barometer, okay, the density of mercury is 13.6 times that of water. Okay, so I would have to have, instead of 760 millimeters, I would have to have that 13.6 times that to be tall enough for the water, because water is what? Less dense than the mercury, right? Alright, and that's it for 6.2, and I will see you back again for 6.3.